Today we're going to look at solving systems by graphing and also by substitution. So the first situation, solving linear systems by graphing, this situation, Mrs. Bayesian loves the new iPhone 6s because it comes in rose gold, but now phone carriers are not offering subsidized phone prices of $199 and $299 if you renew your 2-year contract. Instead, most phone companies have plans where you can lease the phone if you turn in your old phone and upgrade your phones at any time. Here are the two deals that Mrs. Bayesian is looking at. So the first one is Sprint. You can lease the phone for $25 a month and pay $56 a month for voice and data, or you can buy the phone from Apple at T-Mobile for $749 upfront and pay $30 a month for voice and data. So question, which plan do you think is the better deal if Mrs. Bayesian wants a new phone every year? Which plan do you think is the better deal if Mrs. Bayesian wants a new phone every 2 years? What's the independent variable? What's the dependent variable? And why? So let's first start by writing an equation. So for Sprint, we can say y equals, it's $25 a month plus $56 a month for voice and data. So these are both your rates of change. If we add those together, 25 plus 56, it's $81 a month. So our independent variable here is time, which is x, and the dependent variable is going to be cost because the cost depends on the time. All right, so that is for Sprint. For T-Mobile, we can pay $749 up front plus $30 every month for voice and data. So here's the equation. So it says, which plan do you think is the better deal if Mrs. Bayesian wants a new phone every 2 years? Well, X is time, which is number of months here, so this is in months, and 2 years is 24 months. So we can calculate the first one by doing 81 times 2. 81 times 2, actually not by 2, by 24, because it's for 2 years. 24 months. And get this total. So that would be a total of $1,944. And then if we took a look at the other plan, $749 plus 30 times 24, and if we calculate that, let's do that, $749 plus 30 times 24, that will be actually $1,469. So even though T-Mobile starts out more expensive with this phone that you have to pay up front, after 2 years it actually becomes cheaper. It says write an equation for each in slope-intercept form, which we did right here. Y equals 81x and y equals 749 plus 30x. What's the rate of change? So that's how much you pay a month. So here it's $81 a month. Here it's $30 a month. And we looked at the slope. All right, so we did it actually by substitution, and we'll talk about that by plugging in numbers. But let's do this by graphing. So on the TI Inspire, we can open a new graph page, and we can graph these guys and see what it looks like. So for the first one, what was 81x? I'm going to hit enter, and we're not going to see it very well because it only goes to 739. So we will adjust the window. If we hit tab, we can type in another equation. So this is 749. Plus, and it was how much a month? $30 a month. Let me go back. Yep, plus 30x. So let's type that in. It's 30x. All right, and what we're looking for is where they cross. And again, we can't see the other one because it starts at 749, which is way up here. So if we go to menu, window, zoom, zoom fit, it usually shows us our point of intersection. So let's try that. And it doesn't, so I'm going to drag this over until we find our point of intersection. And there it is. Here's where they intersect. And on our worksheet, it tells us how we can calculate the point of intersection. So I'm just following these steps right here. You can go to Menu, Analyze Graph, and find the intersection. Let's try that. Menu, Analyze Graph, intersection, go to the left of your point, go to the right. And here's our intersection. So I'm going to write that down and talk about what it means. It's 14.7 and 1.19 E3. So let's write that down. So this is 14.7, and it was 1.19 E3, which is scientific notation. So if we wrote this down, this is really 14.7. And 1.19 E3 means move that decimal place 3 places to the right. So 1.19, 3 places, 1, 2, 3. All right, so here's really our points right here. In context of the problem, it means at 14.7 months, Again, this is time here, x is number of months. The plans cost the same, and the cost for both plans is $1,190. So that's that point of intersection, what that means. So it says, when would you choose the Sprint plan and why? So if we take a look at the calculator, Sprint was the blue. So we would choose it's cheaper down here, because this is cost, it's cheaper until 14.7 months, which is just over a year. And then T-Mobile becomes cheaper after that 14.7 month mark. So T-Mobile becomes cheaper after that. So you would choose Sprint when your time is less than 14.7 months. And you would choose T-Mobile when your time, if you kept your phone for greater than 14.7 months. Because we can see from the graph that's cheaper after that 14.7 months. Okay. So that's by graphing. If you can put them both in your graphing calculator and find the point of intersection that way by graphing, you can do that. If you don't have a graphing calculator, there's another way to do it. You could solve by setting equations equal. Okay, so by setting equations equal, Anthony and Latrell are running a race. Because Anthony is faster, he gives Latrell a 50-foot head start. Latrell runs at 12.5 feet per second. Okay, so I'm going to write this down. Latrell gets a 50-foot head start. He runs at 12.5 feet per second. And Anthony runs at 14.3 feet per second. How far will they be from the starting line before Anthony passes Latrell? If Anthony wants to win the race, how long should it be? So it says, what's the independent variable? So here again, it's time. But this time, the dependent variable is distance. So if we write their equations, let's do Latrell's first. His is y equals, he starts 50 feet ahead, and he runs at 12.5 feet per second. And that's your rate of change, so we put the x. For Anthony, he starts at the starting line, so he doesn't have a y-intercept. Well, it's 0, but his rate is 14.3. So we could put this in the graphing calculator and find our point of intersection, but really we're trying to find when are these two equal. And so we can solve this problem by setting them equal. So again, Anthony's was that 14.3 feet per second. We can set that equal to Latrell's 50 plus 12.5 feet per second, and we can solve this. So let's do that. If we set the equations equal, when their distances y are both equal, set them equal, and solve. So we're going to subtract 12.5x from each side. And we get 50 equals 14.3 minus 12.5. We get 1.8x. And divide by 1.8 to get x by itself, and x is time. So we have 50 divided by 1.8. All right, so after 27.7 seconds repeating, they are tied. And this is saying if A equals B and B equals C, what conjecture can you make? Well, we can set them equal, and that's what we're getting to, set them equal and solve. So to use substitution, set them equal, that's the first step. Once we find x, we can plug into either equation and solve for y. So again, we're looking at both of these equations here and here. We can plug in for x, 27.7 repeating, and solve. So that's the first step is solve for x by setting them equal. And the second step is solve for y. Choose either equation. I'm just going to choose Latrell's equation. It's shorter, and he had 14.3 x, and we know x is that 27.7 repeating. So we're going to do 14.3 times 27.7 repeating. So I'll put that in my calculator. And here the distance is 397.2 repeating. And this was distance, so I forget if this is in yards or meters. Let's take a look. Feet, it's in feet. So this means if the race is 397.2 repeating feet long, that they will tie. If you want Anthony to win, you'll make the race longer than this. Otherwise, Latrell will win before that. So again, the solution, what does it mean? It means they're tied at that time. So at 27.7 seconds, they're tied, and this is how far they've run. Okay, so then the last thing for substitution, sometimes you have to plug one variable in for another. This is another type of substitution. Here are the steps. Replace the letter with what it equals, distribute, solve, and plug in to find the other variable. So here, look for the letter that's by itself. X is by itself. X equals 8 minus 4y. We're going to plug that in for this x. So this is substitution. Here's what it looks like. 3. Use parentheses when you plug in. 8 minus 4y plus 5y equals 3. Okay, so first step, plug this guy, 8 minus 4y, in for x. Now we only have y in our equation and we can solve. So let's distribute. We get 24 minus 12y plus 5y equals 3. And we'll solve. So combine like terms. Negative 12y plus 5y is negative 7y equals 3. We'll subtract 24 from each side. We get negative 7y equals negative 21. Divide by negative 7, and y equals 3. And we're looking for where do these two lines cross. So we have the y value, we need the x value. So last step, plug answer into the original equation, solve for the missing letter. So we have x equals 8 minus 4y, but we know y is 3, so I'm going to plug that in. So we have x equals 8 minus 12, which equals negative 4. So these two lines do cross, and they cross at the point negative 4, 3. So that's what this means right here. It's supposed to be a comma. Let's try that again. All right, so these two lines cross at negative 4, 3. Let's try another one where we have to plug one into the other. This time y is by itself. Y equals 5 minus 4x. We're going to plug that in for this y right here. So we have 2x minus 3, and when you plug in, use parentheses, we're going to plug in the 5 minus 4x, and that's going to equal 13. I should use pink here. Oops. Okay, so this equals 13. So again, all we did is plug the 5 minus 4x in for y, and now we solve. Distribute, combine like terms. So we get 2x minus 15 plus 12y, or 12x, this is negative 3 times negative 4x is 12x, equals 13. We'll combine like terms here, so we got 14x minus 15 equals 13. Add 15 to each side, and we get 14x equals 28. Divide by 14, and we get x equals 2. Next step, we have the x. We want to see where these two lines equal. We need the y value, so take this equation. Y equals 5 minus 4x, and we're going to do 4 times 2. And we have y equals 4 times 8, 5 minus 4 times 2, which is 8, and we get y equals negative 3. So these two lines, they do cross, and they cross at 2, negative 3. So on your assignment today, you're going to practice this substitution, either by setting equations equal or plugging one in for the other.